Now we'll start with the next or the continuation of the same topic, which is free path, or the term which is very important for the derivation of drift velocity, which is free path. Free means you are very you can move in any way. So path, free path means suppose the electron has undergone a collision at this point, right, and it is going to undergo the second collision at this point. So between this area of this distance, it is actually free, right? It is undergoing collision here, then undergoing collision at the next point. So in between these points or this distance, it is free, and that means this distance between two successive collisions is known as free path. What is free path? Distance between two successive collision. And similarly, there is a term called relaxation time. That means the time where an electron is relaxed. What is the time where they are going to be relaxed? They are going to be relaxed between two successive collisions. So there is a term called relaxation time also. So relaxation time, representation by tau, right, or tau. Relaxation time indicates that the time interval between two successive collisions. Clear? So what is free path? Distance between two successive collision. What is relaxation time? Time duration between two successive collisions. This much clear? Right. Now we are going to consider that the same path. I am going for the same path. The electron is moving like this, random, right? Suppose it was undergoing the first collision here, then it undergoes the second collision. So between first and second collision, the time interval is t1. Now between second and third collision, its time interval is t2. Third and fourth, t3 goes on. And there is n number of successive collisions, so n number of time intervals between them. So what will be the average time between the successive collisions be? That is t1 plus t2 goes on till t and whole divided by n. Right. This gives you an average relaxation time, right, of the single electron, right? So I will write this as relaxation time tau, right? That is the average time interval between two successive collisions of an electron. This much is clear, right? Now we are going with the next one. These are terms which are required, right? Now suppose I am going to consider a conductor and I am going to connect it with the voltage supply like this, right? Now what happens, this is its negative terminal and this is positive terminal. The negative terminal will supply electrons, right? This electron is pushing the electrons which is, or the free electrons present in the conductor towards which side? Towards the positive side. Now this additional push causes the electrons to have an additional velocity, right, other than their what velocity? Thermal velocity, right? Initially the electrons were having thermal velocity when they were not connected to a supply. So when they were connected to supply, the supply is providing electrons from the negative terminal and thus pushes the electrons towards a positive direction, right? And they are getting a particular direction. So other than the thermal velocity, they get an additional velocity, and that velocity is known as Vd, or drift velocity. Clear? So what is the definition of drift velocity? Average velocity with which electrons drift towards the positive terminal under the application of external field is known as drift velocity, and its representation is Vd or V suffix d. This much clear? Now we are going to derive an expression for Vd. That is, I am going to continue with the same diagram. Suppose this is a conductor, you are supplying a voltage V. Suppose this conductor is having a length L and cross-sectional area of A. And since the charge is connected or supply is connected in this direction, the electric field will be in this direction, positive to negative. Right, I am going to divide this with another color. Let's make it as the next section, right? Clear. Now, so this is the electric field direction. This much is clear, right? Now, electrons, what is happening? It is going to drift from positive terminal, right, to the, now what happens is this electron is going to, this much I have told just before, this electron is repelling the electrons of conductor, right, and this electrons will be drifting towards a positive direction. That means this electron from the supply is applying a force, right. That means this force is provided by the battery, right. So there is a force applied, means I can write an equation for it, that is F is equal to QE. This much you know, where Q is the charge of the electron which is being pushed and E is the applied electric field. So in place of Q I can write minus E. Why is minus? Because electron's charge is negative into E. Can't I write? Right. Similarly, there is an expression for force which is F is equal to ma. Right, this much you know from +1, I think from 9th itself. So there are two expressions for force. I am going to equate them, that is ma is equal to minus ee. So I can write A is equal to minus electric field divided by m. Make it as a one expression, we require it for later on. That is, this gives the acceleration provided by the supply to the electrons. What is the A? A is acceleration. So A represents the electric acceleration, or the acceleration which is provided by the supply to the electrons to move from one terminal of the conductor towards a positive terminal of the supply. This much is clear. So you will see a negative direction or negative sign in the expression. This negative sign indicates that the electrons are moving or accelerated in opposite direction as that of the electric field. See, the electric field is in this direction, but the electrons are drifting in this direction. So electrons drifting is in opposite direction of electric field is represented by this negative sign. Clear? Right. Let's move on with the derivation. I hope you remember the Newton's laws of equation or equations. First equation was what? V is equal to U plus AT. Right. So what was the parameters here? U is the initial velocity of the object, A is the acceleration, T is the time interval, and V is the final velocity. Now here the electrons are moving. So what is the U for this electron initial velocity? It is the thermal velocity, right? So T will be the what? Time period between successive collisions, and V is the drift velocity, because that is the final velocity achieved by the electrons, right? So let us consider for each electron. So each electron has its own drift velocity, that is Vd1 for the first electron. Its initial velocity is thermal velocity plus acceleration is new acceleration divided by the time period, that is first successive collision, right? T1, right? Clear? Similarly for n electrons I can write like this: Vd2 is equal to U2 plus A2 T2 goes on, Vdn is equal to Un plus An Tn goes on, right? Now what would we do? Whenever you are asked the velocity of an entire object, you have to find the average, right? So what is the average of these two? All of this is average will be Vd1 plus Vd2 goes on Vdn whole divided by n, right? This much is average. Now we are going to put these values in this expression. Now what happens when I put it in the expression? So just what Vd1 plus Vd2 goes on Vdn whole divided by n, right? So I'm going to represent it as, it becomes U1 plus AT1 plus, sorry it's not clear, plus U2 plus AT2 goes on U1 plus ATN whole divided by n. Now I'm going to take the terms, sorry, this is A1, A2 and this is AN, right? Now A1, A2 to AN. See, there is single supply only, right? And the single supply is going to give a single type of push or force, and the mass is constant because the electrons are constant. That means acceleration is always constant, right? force is constant, the push is given by the same guy. Now the particles are also same, so mass is constant, so that means acceleration is also constant. So all these terms will be equivalent to A itself. This much clear? Now we are going to write the same in the previous equation. What happens? I'm going to bring the terms which are quite like that is u1 to un, common type in one section, plus A is common. It becomes T1 plus T2 goes on Tn. Then whole divided by n. Right. Now previously we have told that average thermal velocity, that is this much terms, is equal to 0. Remember, when the electric field is not applied, so the average thermal velocity, that is the velocity of a particle or electrons when there is no supply given or due to the atmospheric temperatures, average is always 0. So this term goes off, so the entire things, this much part is going off, so that I can write Vd is equal to A T1 plus T2 goes on till Tn whole divided by n. Now guys, what is this term? That is this term. It is your relaxation time. So Vd is equal to A into tau or tau. Right? Clear? So you get a drift velocity here. Now you have written the expression for acceleration previously. Right? Here you mentioned this A as modulus A, that is you don't require minus, or if you write minus also is okay. So because Vd is equal to A, from previous section I have written or found it as capital E into E divided by M into tau. This is your expression for drift velocity with